example 3 of solving for a three-variable system of equations. So we got these three equations here denoted by capital A, B, and C. Now notice that except for equation C, equations A and B are not in standard form, because the standard form of three-variable equations is something multiply x plus something multiply y plus something multiply z equal to a number. Well, if you look at the A and B equations, I got x, or from left to right, I got x, z, and y. And then from here, I got y, x, and z. So it is not x, y, z as required by the standard form. So I had to rewrite these two equations in standard form. Just switch places of the term in these two equations. So for the first equation and the second, I'll bring it over here. For the first equation, I can rewrite it to be minus 9x minus 6y minus 3z equal to 96. And for the second equation, it's going to be 6x plus 6y plus 6z equal to negative 78. And then, of course, keep the last one the same. Right? Now with these three equations, looking at all of the coefficients, it is already convenient for me, because when I look at all of the y's, I got minus 6 times y and then plus 6y plus 6y. So it seems like the y variable is going to be the easiest one to be eliminated to come up with a two-variable system of equation, to solve for one of the first three variables. So I'm going to eliminate a y by selecting two of the three equations. So I'm going to select capital A and capital B. To put them together, so for A, I got minus 9x minus 6y minus 3z equals 96. And then for B, I got plus 6x plus 6y plus 6z equal to negative 78. Now when I add these two together, vertically, minus 6y and plus 6y cancel out. I'm left with minus 3x. Negative 3z plus 6z is plus 3z equal to positive 18. Now, looking at this equation, it actually can be simplified a little more, because the coefficients negative 3 and plus 3 indicates that I can factor out a number. So I'm going to factor out negative 3. So factoring out the negative 3, I'm left with positive x minus z, and then equal to 18. And then divide both sides by negative 3. I simplify my equation down to x minus z equal to negative 6. So this is my new equation denoted by capital D. So let's go back here and select two other ones and eliminate the same variable. So I'm going to eliminate y after I select capital A and capital C. So select A and C. I got negative 9x minus 6y minus 3z equal to positive 96. For C, I got minus 4x plus 6y plus 8z equal to negative 10. And add these two equations vertically. That means minus 6y and plus 6y cancel out. Just like earlier, negative 9x minus 4x is negative 13x. Negative 3z plus 8z is going to be plus 5z. 96 minus 10 is going to be 86. So this is equation capital E. So when I put these two equations together, that will be my system of two-variable equations. Now at this step, do I want to substitute, eliminate, or graph? Well, let's see. I can substitute, but I feel like that's going to be a little more difficult than eliminating. So when I compare all of these variables, this z term and this z term, they have the minus and the plus side. So hey, that's already something that I can work with. And even over here, I got a positive x and I get a negative, a number and x. So positive and negative again. So I get to select whether I want to eliminate the x or the z. Well, I feel like eliminating the z is going to be easier for me because I can easily convert this minus 1z into minus 5z and add these two equations vertically to take away the minus 5z and the plus 5z, leaving me with just the x term equal to something. So that's what I want to do. So I can convert this minus 1z by multiplying the entire d equation by positive 5 and leave the e equation alone. So by doing that, my new d equations is now going to be 5x minus 5z equal to negative 30. And my e equation stays the same. So I got minus 13x plus 5z equal 86. When I add them vertically, 5x, well, the minus 5z and the plus 5z cancel out, so we don't have to worry about that. 5x minus 13x is going to be negative 8x equal negative 30 plus 86 is the same as 86 minus 30, which is positive 76. I mean, not 76, positive 56. Well, divide both sides by negative 8. I'm left with x equal negative 7. Now with x equal negative 7, I get to go backward and select either equation D or equation E to solve for the second variable z. Well, in this case, I'm going to select equation D instead. So my work is going to tend to get a little messy here, but because I don't want to go to another piece of paper, that's why. So I'm just going to sketch it over here. Then bring this up. So basically, I'm indicating that I'm selecting equation D, and I'm plugging in the value of x equal negative 7 into equation D. So equation D is x minus z equal to negative 6, but x equals to negative 7. So basically, I'm going to have negative 7 minus z equal to negative 6. So that means I'm going to have, well, add 7 to both sides, actually. I got negative z equals negative 6 plus 7 is positive 1. Divide both sides by negative 1 to get z by itself. I got z equal to negative 1. So x equal to negative 7. Oops. X equal to negative 7 and z equal to negative 1. Take these two variables and select one of the three original equations, plug them in, and solve for the leftover y. So in this case, I'm going to select the second equation B. So choose B. And then because I'm almost out of space here, I'm just going to plug them in straight. So I got 6x plus 6y plus 6z equals to negative 78. But x is negative 7 and z equals to negative 1. So that means I'm going to have 6 times negative 7 plus 6 times y plus 6 times negative 1 equal to negative 78. Like that. Hopefully you can see it there. Well, let's see. Negative 7. 6 times negative 7 is negative 42. 6 times negative 1 is negative 6. Negative 42 plus negative 6 is negative 48. So that means I want to have 6y minus 48 equal to negative 78. Add 48 to both sides to get closer to the y. I'm going to have, here, I'm going to indicate that. I'm going to have 6y equals, well, negative 78 plus 48 is going to be negative 30. And divide both sides by 6. I got y equal to negative 5. So the solution to this system is negative 7, comma, negative 5, comma, negative 1.